So welcome everyone. I'm super excited to be here to talk with all of you about how we can demystify Apache Spark to better understand what Apache Spark is, how we can incorporate it and use it in our different product that we're building. My name is Polak. I'm a senior cloud advocate with Microsoft. I specialize in data and AI at scale technologies, specifically distributed data and distributed data computing parts. So I hope you enjoyed today's session. A little bit about where you can find me on social media. So you can always send me a private message on Twitter, on LinkedIn. If you have any career message, you want to consult about specific data and AI topic that you don't know what to do, or you want to learn something new, or you want to enter the data and AI tech space and you want some advice, feel free to ping me. And if you want to read some stuff that I'm writing on Medium and Dev2 mostly. And our agenda for today, we're going to start with an introduction to what it even means to write code, what we learn when we learn to code, what is Apache Spark, and then what are ETLs with Apache Spark. And don't worry if you don't know what ETLs are. By the end of the session today, you will definitely understand what it is and how to use it. All right, so let's start with the beginning. What happened when we starting to learn how to code? We usually, when we start to learn how to code, if you look at all the syllabus, we usually start with some numbers and assignments. And this is a Python example of how we can assign different variables and how we can assign numbers to different variables. For example, x equal 1, and then y equal x plus 5, and then z equals y. So this is like a very simple example that we do. And the next thing is we learn about types. We learn about different object types like string, like integers, like Boolean, and so on and so forth, depending on your programming language that you are working with. And the next step after that is reading some input from the command line or from the terminal. So we're starting to experiment with, if we work with Python, we start to experiment with different input. So we can enter our name, process the data a little bit, and then print back to the command line or the terminal that we are working with. So this is usually the second step. And here we are actually introducing data that we don't know what its type is going to be most of the time, especially when we work with Python. We just ask the user, hey, write your name, enter your name into our system, and we're going to process this data for you. And then after that, we kind of progress and we continue to evolve and we learn to work with more complicated data. We work with files. So this is a Python example on how we can read files from our devices. So we can open the file and then we specify what we want to do with the file. So here we're giving it R, and R means we want to read the file. And then we're just printing it with the print functionality. And what actually happens on our device, on our machines, when we run it, we have the program, the process that runs our program, and it communicates with the hard disk and with the files we have there on our machine. So it's all localized, all on one machine. Later on, we're evolving, and we start to learn about databases. And wow, there is some server somewhere that is hosting a lot of data. It might be one machine, it might be multiple, but we'll get to that. We'll start with one machine first. And here in the example, we're kind of learning how we can connect to MongoDB. So we understand, okay, instead of reading a file from my machine, or instead of reading a file from the command line, I can connect to a MongoDB somewhere, something like that exists, and actually run some queries and ask it to get more information. So this code example shows me how I can connect to a Mongo client and read information from the DB itself. And what it actually means, it can be that my Mongo database is running on my machine, but most often it will be somewhere on other machines that my process communicates through the network, through the internet, to some databases and bring in more information. All right, so we understand that data runs on the network, so we can deliver and run data on our network. But you know what? What if our data is too big and one Mongo machine is just not enough? We need to have multiple machines to host all that data that we want to work with. So this is where we enter the space of distributed data. And for our use case with our database, it's going to be a distributed data database, which means my Mongo machine can also be distributed. So I can have multiple disk, multiple machine, where every machine holds one chunk of the data, and then I will have another machine, which is the database manager that helps me with all the queries and all the information that I want to retrieve from these machines. So I can have my app running, on my laptop or on one machine, and then I'm communicated with the database manager that actually goes and communicates to multiple distributed machines to retrieve the information that I want. All right, and now we're progressing, right? What if all the data that I want to process, so my query returns more information that I can process on my machine. So for example, I'm sending a query to the database manager and the database replies with an answer that is too big and I can't really process it on my machine. And this is actually where we understand that sometimes we need something called distributed computing. So let's go to the start. We said we have some database manager that knows how to work with distributed data. And because the distributed data that I get back from this database manager is too big, I'm going to distribute my computing part, distribute my processing part. And how it's going to look like, it's going to look like every machine that I have, I'm going to have multiple of them, is going to run a specific logic on a piece of data. And since my logic is similar, because at the end I want to process all this data in one specific logic that I'm building, then it's going to be the same logic for all machines. And what is going to be changed, the only difference is going to be the actual data that's there. And this is what it's called distributed computing. And distributed computing can be, can come in different shapes, like what we saw before, and it can come in also this shape, and it can be more and more complex, depends on the logic that we want to build, the amount of machines we have, what we actually want to achieve, what the different queries that we're running, right? If we're running join query or select query, and we'll see it soon. All right, let's think about an example of what it means to actually sort a tons of data. And a great example for it is candies. So let's say I have 50 kilo of candies and I only have 15 minutes to sort them. So someone gave me a task and said, Adi, sort this 50 kilo of candy in 15 minutes. Well, if I want to sort like half a kilo of candy, it's going to take me at least half an hour because I might be eating some of it along the way. So I definitely, I need my friends to help me. So what I can do, I can collect all my friends and tell them, hey, friends, I need to sort this candy. And what I'm going to do, I'm going to give each one of you a kilo of the candy. And each one of you is going to sort it on your side. So first you're going to sort it on your side and divide it by colors, and then we'll see what we can do next. So after they're sorting it, and we kind of can see here from the example that different people get different colors of candies. So that's perfectly fine, because after it, we're going to merge all these candies. And when we're doing the merge operations, we are going to merge it in a way that the same colors go with the same colors. And if there isn't a pile of that color, we're going to create a new pile of that color, just like this one. So the yellow went with the yellow, the blue with the blue, the green with the green, and the red with the red. And this is exactly how Apache Spark operates behind the scenes. Behind the scenes, it takes all the information we need with a different logic. So here we saw a sort logic. So every person and every machine sorted the data they got locally. So sorted the half kilo or kilo of candies they got locally, and then they merge it together. And this is an operation called MapReduce, where we're first mapping the data, sending all the candies, splitting it into small chunks that people can process, and then reducing it and combining all that information back to get the results. So you already know a little bit what is Apache Spark, because we said it's, it helps us sort candy, and that's fantastic. And it gives us much more opportunities and much more tools that we can do. It's actually one of the leading engine for big data processing. And also, if we want to do distributed machine learning and build machine learning on huge scale of data, then it helps us there. It provides with a lot of functionalities like stream processing, batch processing, machine learning, building machine learning at scale, graph processing, and the community always keeps on adding more and more into the Apache Spark ecosystem. And the nice thing about it, it's an open source, so you can dive in and see how it works and start playing with it. And the way it operates, it usually the functionality inside Apache Spark, the API can be split into transformation, and action. And the reason for that is because Apache Spark is considered, when we look at different programming language and different programming architecture, it's considered lazy. It uses a lazy computation model. And lazy computation model means I'm not going to do the command until you're going to give me like a magic command that now going to tell me, hey, start running this process. And the reason it does it so it can optimize a different workload. Assuming, I have this 50 kilo of candies and I want to sort it. But, after I'm sorting it, no one is going to use the sorted candies. And if Apache Spark engine detects that no one is going to use these sorted candies, it's actually not going to tell anyone to sort it because it's lazy. It's first going to look for someone who is actually interested in these sorted candies before it does that specific action. And you can look at the list of transformation. It can be mapping, filtering, group by key, reduce by key, sort by, map different values. And these are all nice, but before I actually tell it, hey, collect, reduce, count, save these candies to a specific place, or let me take a look and pick at one of the candies, it's not going to do its task. And that's an important thing to understand about Spark, especially when we start working with it, because most of the time we're like, hey, it didn't do what I asked it to do. And the reason for that is because we never called action. So please remember, take away calling action when you start to work with Apache Spark. And okay, we said it's a distributed systems. We said there's a lot of operations. There are SQL operations, there are machine learning operations, there are streaming operations, but we can divide it like very high level into narrow transformation and wide transformation. And the reason we divide it into two sections is because the compute and networking. What it actually means when I need to do narrow transformation, it means that all the information that I'm processing can still be processed on the same machine. So for example, if I'm doing a specific filter operation, I can keep the data in the memory of one machine. And after that, do another filtering, and I don't need to write this information back to the disk or send it over to the network to the other machine until I'm actually doing a reduce or any actionable request. And the other way is the wide transformation. And wide transformation mean, although I did my sorting, for example, on one machine, now I need to combine my results with results from the other machines. So I have to send this data over the network. And this operation of sending this data over the network called shuffling, because we're going to send the data from one machine to multiple machines, and every machine is going to do it. And you can only imagine if you have a cluster of 100 machines, that means a lot of network is going to take place. And this operations is something that we do, but we need to understand exactly what we're doing, when we're doing it, because when we have 50 kilos of candies, or when we have 100 gigabyte of data or terabyte or more than that, we need to understand what the overloads on the network means, how long it's going to take. Do we really need this specific operation, or is there something else that we can do? So you can see there are the narrow transformation, for example, the filter, the sample, the union, and there are the wide transformation, which is if I want to do some distinct count, if I want to do a join, if I want to do a Cartesian or co-group or repartition of the data. Just remember, you can do everything, but be mindful of what you're doing and the different operations that you're using. All right, so let's look at the architecture of the cluster. What I have when I work with Apache cluster, I have two types of nodes. I have the driver node and I have the worker node. And the driver is the one that takes in my code, process it, and distributed it into different tasks. And the driver node will have the driver program running in it. And the worker node will have the executors running in it. And how it works, the driver is going to take my operations. I'm going to give it the SQL query or the machine learning that I want to run or the different graph computation that I want to run. It's going to split it up by different tasks, depends on where the data exists. And then it's going to send this logic to the worker nodes, to the different executor nodes, and ask them, hey, can you please run this workload for me? So if we're going back to our candy example, in our candy example, we're doing sorting. So the driver node's going to say, hey, we need to sort 50 kilo of candies. Each worker now is going to sort half a kilo, and we'll get the answer. So it's the same logic. It's just different workers will have different chunks of the data. And you're probably curious what happens inside this executors. They're, inside the executor, usually running JVM. So if you're familiar with Java, this is the runtime for Java, and it can have multiple tasks. So it might be that one executor is now sorting half a kilo of candies, but within the same executor, there's another task that runs from a different job that Apache Spark, the driver of Apache Spark, sent to him. And that's perfectly fine. And this is how it works and how it can parallel the different workloads. So it's not only distributed, it's also parallel within every machine. And you can see there are a lot of different operations, and everything is kind of saved into the memory. Another operations that exist is the caching mechanism. And the caching, we can say, hey, I'm going to work with this data again and again, so please cache it into your memory. And to be honest, it's more of an advanced thing that we can do, and the recommendation is trying to avoid it. But you should know about it because, in all the books, in all the syllabus, everywhere they talk about caching. But again, many times it's something that doesn't really help or support the workload, and it's just, being that something that sometimes we use because we saw it somewhere in some book, but it's actually doesn't really help us do our workloads faster. But again, you should know it exists. And of course, then we have the tasks that are running in our executor. So sorting out half a kilo of candies. And you're probably curious about, hey, there's a lot of good functionality, but what are the programming language exactly that I need to know to run Apache Spark? So Apache Spark has a core, and it depends on where you're running it, but it can be C++. Now that we see it in Databricks, they change everything to C++, but it's mostly within the Java and the Scala world. So everything related to the JVM. And then on top of it, there is an interloop layer that helps us communicate and use Apache Spark with various other programming language. So if I want to work with R, I have a way to work with Spark R that enables me to use R to run Spark workloads. And if I'm a fan of Python, then I have PySpark, and I can run Spark leveraging Python. And if I'm working with .NET, and I'm a fan of C# and .NET ecosystem, so I can use .NET for Apache Spark to run my workloads and do all the things with Spark. So this gives us a nice set of capabilities. And also, if you're interested, the community are continue to develop more and more support for different programming language. Recently, I saw Kotlin is getting supported for Spark by JetBrains, and there is JavaScript as well that now the community start to support to run Apache Spark using JavaScript. So there's a lot of support in the community already, so you don't have to tie yourself to a specific programming language. You can pick the one that you're already using and knowing and love. All right. And we said Spark is a computing engine, right? It's a distributed computing engine that enables us to run compute on distributed data. But how do we connect all this data? How do I tell Spark, hey, I want to run this specific data? So Spark has something called Spark connectors. And Spark connectors is an interface that we can implement, and we can use it to connect to different databases and different storages and file system. For example, out of the box, it supports Parquet, CSV, and a lot more. And also the community helped develop the connector. So in most of the cases, you will not need to develop your own connectors. So if you're working with databases such as Elasticsearch, for example, or if you work with Kafka, or if you work with MongoDB, Cassandra, Hadoop, Postgres, Cosmos DB, Azure Data Explorer, and many, many others, you will mostly see that there is already a Spark connector. And all you need to do is say, hey, I want to use this library that gives me that Spark connector. So you don't need to create it on your own. And this is really easy and nice because you can connect multiple databases and multiple data sources into your application without really thinking about it, and have a nice interface to kind of do your computation on multiple databases and all in one place. All right, it's cut o'clock, and we're going to go through an example of how we can run Apache Spark. We're going to go through a specific example of ETL, and ETL comes from the data world. It talks about extract, transpose, and load. It's actually mean we're going to extract the data from some source. It can be a database, it can be a file, it can be, maybe Kafka. If I want to extract the information from Kafka, I'm going to run some transformation on the data. I'm going to change it a little bit. Maybe I can add feature. Maybe I want to filter out feature. Maybe I want to do join with different tables. And then I'm going to do load. And load in our case is going to be sync. Sync means I'm going to sync that data in a new database or save it to my file system. So this is what we're going to do with Spark today as an example of how we can work with Spark. And this is like the very high level basic operations that we usually think of when we work with data and when we work with massive amounts of data. And we're using PySpark, which means everything you see is a Python code. And if you're not familiar with Python, don't worry, we're going to go line by line, and it's going to be super clear and easy for you to understand. So when I start, I have something called the Spark context or the Spark session. And using that Spark session, I can call my connectors through read. And I'm just writing the function. I'm saying, hey, I'll take my Spark connector or my Spark session, and I'm going to call read. And from the read, I can specify the file type or the database type that I want to work with. Here you can see I specified and said, hey, I need a specific connector for Parquet files, and I'm going to give you my directory or my file for where this information exists, but please process it as Parquet file because this is what I'm expecting. And you can see it's going to take all this information from the Parquet file, and it's going to assign it into a new variable named input data. And the input data is going to be my data frame, which means it's my object to do different operations on Apache Spark. But you probably remember, because you're smart, it's lazy. Right, it's lazy, which means it didn't yet load the data into the different machines. And that's perfectly fine, because if I'm not going to do anything with that data, it's actually saving me resources and times. So only if I'm going to do something specific with that data that you're going to see later on, it's going to load this information. So this is part of our transformation functionality that we're doing. And what we have in the transformation, in the data, every row holds an ID, a first name, a second name, and floor level. So basically employees in the office where I'm storing ID, first name, second name, and floor level of where they're sitting. All right, we loaded the data. Now we want to transform the data. We want to run some SQL, or we want to run some functionality to change and transform our data into something else. So I'm taking my data frame that I already created. I'm taking my input data, and I'm going to call select. And select is from the SQL world saying, hey, I want to use this specific column. So I want to take from all the columns you suggested. I want to take here, for example, the first one is going to be ID. Okay, so give me the ID column. All right. Next, do concat WS. And concat WS, what it does, it concat different strings for me. Okay, So I know my first column is going to be ID. The second one is going to be some concatenations of string. So I'm going to do concatenation of the first column, which is the first name, and then the second column, which is the second name, and I'm going to give it a specific alias. So this column is going to be called name. So I'm connecting two columns and giving it the name name. All right, so I have ID, I have name, and then my third one is going to be, oh boy, it's a little bit more complex. All right, so I'm taking the column of floor, and I know it's an int number, and I'm doubling it by steps per floor, and lit is just a function that helped me translate everything back to the Spark framework. So steps per floor. All right, so this is my third column, and I'm giving it the alias steps to desk. Okay, let's look at our first local record. We have row ID = 1, first name Dan, second name Jermaine, floor number 1. So how it's going to translate after I'm going to run this transformation, I'm going to have ID 1, and then I'm going to have name Dan, Jermaine, and then I'm going to have the floor, and I'm going to, it's going to be number 5 here, because for every floor I have 5 steps to the specific floor. All right, so it means the steps to desk, it's going to be 5. All right, awesome. And all of this information and all of this calculation that I now did is going to be represented in a new data frame, and I'm going to assign everything to a new data frame called data frame transposed. And this is going to be my new data frame that went through the first transformation that I did. So if we look now at what the data that I had when I started it and what the data that I have now, if we look at row number 8, I have the ID 8, first name Kim, second name Souther, floor 4. And now this information transformed and translated into a new data frame that I'm holding, where the ID is 8, the name is Kim Souther, and the steps to the desk is 20. All right, I understand the transformation. I understand how to do it with Apache Spark. Now, how do I do the last part of actually loading it or saving it, or making sure it's actionable, it's actually taking place? Because all we saw up until here was, things that are not yet actionable. It's just in a transformation phase in Apache Spark. So what I'm going to do, I'm going to take this data frame that I have, the data frame transpose, and I'm going to call coalesce. And coalesce is a very unique function that, let's go back to what we have when we had the distributed data on multiple machines. Coalesce, what it does, it takes the number that I tell it and then say, okay, you want all this information to be shrunk to how many machines? And it does that for me. So we need to be very careful with when we're using coalesce, and we need to understand what exactly it does for us. So if we don't have, for example, if we don't have enough space in the disk to actually save all this information into one machine, so into coalesce of 1, we're going to get errors. In our case, we have enough space, and it's relatively something that can be fitted into one machine. But again, it's something that you should know. And usually when we work with big data, we kind of do all this transformation and all this filtering. So we take like terabyte of data, and then we filter it out so much that we kind of reach the phase, hey, you know what, now I have 20 gigabyte of data, and it can fit in one machine, so I don't need to keep it in a distributed manner. So this is where coalesce really helps us. Also, if we'll take it into the machine learning space, usually in machine learning, when we work with machine learning, we get a lot of data in the beginning, and we need to kind of filter out and find out what is the dirty data and what is actually the valuable data. And Apache Spark helps us do it as well, to filter out using all the functionality it has built in. And most of the times after we filter out all the dirty data, we kind of left with something that is relatively small, and we can load it on one machine. So we don't need this massive architecture of Apache Spark. So we can use the coalesce and tell, hey, now save it, coalesce it to 1, and save it into one machine. And then we can call the write functionality, saying we're going to write it. And this is, again, going back to our Spark connectors. And we're saying we want Spark connector, we want to be saved in a Parquet mode. And it's going to save all this information for me in a Parquet mode, and I'm specifying the file that I want it to be saved at, and also the mode that I want it to be saved at. If I'm not specifying the mode, the default for that will be the write mode, and if a file like that already exists, it's going to throw out an exception saying, hey, a file like that already exists, I can't write it there. So if you know something like that might be already in the system, specify the overwrite mode if you need to. But again, it's kind of a help us stay in line so we won't run the same computation again and again. It's actually check everything for us before we're doing the process, and it's something important to keep in mind. And a few sentences about Parquet. Parquet is a columnar file format that helps us save all the information in columns instead of rows. So if we'll go back to our example on what we had with the ID, the first name, the last name, and the floor, actually each one of the columns is going to get its own file because we're saving it by columns and we're not saving it by rows. And it's really great when we need to do different data exploration or analytics, because most of the time we will ask for very specific fields that we want to work with, and we're not going to need the entire row or all the columns that we're working with. And this kind of helps us to just read the only file that we need for this specific operation. So if I only need the ID and I want to filter by the ID, or if I just want to filter by the floor number that I have, I can do it pretty easily with pretty fast with Parquet, because I'm only saving it by the column itself. So I don't need to read a lot. I just need to read one file, and it's going to be short because it holds only the column. All right, so this is how we're building ETL. This is like the very simple way of how we can work with Apache Spark and also in the world of data processing. And you're probably curious, okay, I know it's a distributed compute engine that helps me process a lot of data, which means most likely when I want to work with it in production, I don't want to run it on my machine. So I'm going to go to the cloud and seek for a place that already, have it somewhere installed that I can only want to interact with the different functionality and the libraries that Spark gives me. And you're right, not all of us have to be expert on how to install Spark and how to run it. And the cloud does give us a lot of opportunities and a lot of tools to work with Apache Spark. And if we look at the list, we can see we have HD Insight, and HD Insight gives us the ability to run open source Apache Spark and also other open source types. So if you want to run Kafka, or if we run different types of open source that we want, it kind of gives us the Hadoop space to run Apache Spark at. So this is one of the options we have. The second one is Azure Databricks. And Databricks is a fantastic tool, especially if you just want to open a notebook and start writing your own Spark code. They also have 14 days trial version on Azure, so you can try it out for free. And they also, Databricks specifically has a community edition. So you can go to the website, download the Databricks community, and start using it on your own machine and run Apache Spark workload. I will say that it's not going to be distributed, and you're not going to feel all the, the greatness of the distributed compute, but you can start exploring with the functionality and kind of get a more experienced and understanding of the different functions that exist and how to work with the libraries. Another option is AKS. It stands for Azure Kubernetes Service, and you can deploy Apache Spark into Kubernetes services. There are different tutorials on Microsoft documents on how to do it. It's a more of advanced options because you need to know how Kubernetes work and how to deploy this distributed computing onto Kubernetes. And then another option is Synapse. And Azure Synapse is a new product that's going to be GA soon. It's still in public preview, that enables you to deploy Apache Spark pools, we call it, and interact with Apache Spark directly from the UI through a notebook, and just start writing immediately without thinking about all the infrastructure and the machines and everything around it. So you have a lot of different options, and also you can always run it locally. And if you work with Docker, There's a Docker image as well, so you can run it. It's another way to run it locally on the machine. Awesome. So I really hope you enjoyed today, and thank you so much. We'll do a quick wrap up. We start with understanding how coding integrates data into our lives. So very simple command line, reading from files. And then we went all the way to distributed data and all the way to distributed data with distributed computing. And I really hope you enjoy today's session. And if you have any questions and want to connect, you can always contact me on different social media channels. So thank you.